Okay, let's do some more Lewis structures and VSEPR geometry. All right, there are three central atoms in this molecule. I'll color code this here. Silicon has 4 valence electrons, plus a 3 from each of the hydrogens, 3 from all 3 hydrogens. 7. Put silicon in the center here. Put hydrogens surrounding it. We're going to need 3 bonding pairs. All right, so that's 6 valence electrons used there, and we have 1 remaining. We're going to use that to make the bond with the next central atom, which we'll do here in green. Sulfur has 6 valence electrons and fluorine has 7. There's 2 fluorines, so let's multiply that by 2. 14 plus 6 is 20 valence electrons. All right, sulfur is going to go in the center. Put the fluorines around it. Let's get 2 bonding pairs, 1 for each fluorine, and that's going to use up 4 valence electrons. We're down to 16. All right, let's get the octet going on the fluorines. We could do that by giving each fluorine 6 valence electrons. So we've used up 12 to do that. We're down to 4. We're going to need 1 electron here to complete the bonding pair with the silicon on the left. And then we're going to need a 1 for the bonding pair with the carbon on the right. So we have 2 more remaining. We'll put that right somewhere there on the central. Does it look better? Yeah, it doesn't matter. All right, I'll put it there. All right, and then finally, carbon has 4 valence electrons plus 5 for the nitrogen. Let me a little better here. 4 carbon and then 5 for the nitrogen. We have 9 valence electrons there. Carbon's going to be in the center. Let's use 2 for that bonding pair between the carbon and the nitrogen. So we have 7 remaining. All right, let's get the octet going on the nitrogen. That's 6 of them there. We're going to need 1 to make the bonding pair with the sulfur on the left. Okay, so we've used up all our valence electrons. All right, carbon needs an octet, so we're going to need to move 2 of these lone pairs over to make a triple bond. You may recognize that as a cyanide. And let's, can I erase some of this stuff? That didn't work. Okay, so let me try something else. There we go. Good. All right, let's do the geometry around the silicon atom. There's 3, whoops. There's 3 silicon, what am I saying? There's 3 central atoms. All right, silicon has, good, how many electron domains does it have? Okay, it has 4. No lone pairs, right? So it's tetrahedral, 109.5. Right, so the bond angles there are 109.5 degrees. And its tetrahedral is a geometry around that silicon. All right, what about sulfur? How many electron domains? It has 5. Okay, and 1 lone pair right there. All right, 5 domains, 1 lone pair. So 5 domains, 1 lone pair. It's a seesaw. Okay, so the geometry on the sulfur is seesaw. Now, man, it's going to be tough to do this. No, wedge and dash. All right, so these are going to be 90 degrees or slightly less than 90 degrees. And this fluorine to the other fluorine is going to be slightly less than 120 degrees. All right, I got it. My drawing's like flipped from that one. Okay. Yeah. Okay. Let's do carbon is the final central atom. How many electron domains? That's right, there's 2. So that's 180 degrees between the in the central, the bond angle between the sulfur, carbon, nitrogen bond angle is 180, and that's linear. For the last, the geometry for the around the carbon is linear.